You are welcome to today's tutorial on Geodatabase. As we have been considering since, we have talked about 4 major tasks in our tutorial. We talk about how to organize our data in our catalog, importing data into your database. Then we talk about creating subtype and attribute domain. Then we also talk about creating relationship between objects. Now, before I proceed with the tutorial, I want to show us, because today we will be talking about building geometric network. I want to show us some practical applications or a case study. Let me call it a case study because it may not be real practical indeed, but I will be referencing this thing with some real life example that actually related to us, so that we know how we are going to apply these techniques that we are learning in solving real life problems. Even if we have not gotten it in full now, by the time we see the type of problem we want to solve, we can quickly reference this tutorial and see how we can solve the problem. So first, I show us on one of the projects we did sometime when I first start this course. There's a database that was created in regards to that project, and this is the model. You see that in this model I have up to like 10 entities, and out of these entities I have plots as the only spatial data. As you can see here, it's the only one that have geometric data, and every other data are related to it, either using the primary key or using the foreign key. They are related to it. Now, when you look at this, sorry, let me drag this. When you look at this very well, you see that this data is coming from a lot of departments, especially lands department, tax revenue department, land use charges department. If there is no proper database modeling, to integrate data from different departments will be very, very difficult. And that's one advantage of having a very good and solid database. Now, we call our own geodatabase. The reason why we call it geodatabase is that it has a relationship with a location. So, but it's not only a location data that we use. We use other non-spatial data. Like now, proprietorship. Proprietor is the person that holds the land, and he has a primary key. The owner has the ID. And which land does he hold? That's the proprietorship. He holds a parcel ID. Which parcel? Then you see that the primary key is referencing this plot primary key. So we can create this in ArcGIS, model our database with all what we have been learning, and at the end of the day, we have a comprehensive enterprise database that can be integrated with any other data out there. This is one of the things that our country lacks presently, and that's why a lot of problems remain unsolved. We don't have a solid database that can handle a lot of problems. And in fact, if we have a solid database, there are some information, there are some decisions that will come out from that database that even we ourselves will be surprised of what we are seeing. So I want us to know that. So it's very important when we are doing any GIS project to have a very solid database. Actually, it depends on the type of project, but a very solid GIS project will require a database model. And also, before you start any GIS project, you have to do what we call user analysis, user assessment analysis. What are the things you want to solve? How do you want to solve it? You have to analyze and plan such a thing. So this is one of the things that we for this modeling to us, just for us to take a look at it. So as the tutorial proceed, I will also show us some practical applications of what we want to study today, especially today's study that based on geometric networking is very, very, very important. And in one way or the other, we have been using this unknowingly. Many of us use Google to search for places, even to transit ourselves. There's one application we are selling in our office like that. It will tell you where to branch, where to go. How does it know which route you have to take to your destination? It's because these features are connected together. They have a network. There is a relationship. Those features they have some behavior. So anytime you are using it, it applies those behavior to solve your problem. So that is what we are going to be looking at today. And I will take it very slowly. Then where I need to draw some things, I will actually draw it so that we can understand. Pray God will help us. So now we are in exercise 5. Building a geometric network. Now, in our case study here, the network we want to build is our water network system. Don't forget, we have parcels of land, and each parcels of land has its own owner. And there are there are water systems supplied to each parcel. Just think of each parcel as a completed land that a building is on top. In fact, if we want to elaborate this project, we have another entity called building. So building will always be related to a parcel. So, and for any building, they need water system. So how does water provision relate to every parcel in this case study? That's what we want to look at. And we are going to look at two major things in this building of geometric network. Number one, we are going to create what we call, let me zoom in so that we can see it. Okay. So firstly, we build a geometric network, that's number one. Then number two, we create a connectivity rules for that geometric network. Now, the first step to start is inside our geodatabase, which is here. We right click, we go to new, we go to geometric network, and it will bring out this dialog box. Now, The next step is to say, okay, next. Oh, sorry. It's like I have to off some things in my, I have to off this. Sorry, it's disturbing. So now enter a name for the geometric network. That's the first thing. The name we are going to be giving it is water network. It says now feature within specified tolerance. We leave it as default to be no. So we click next. Now, it said because we are dealing with, if you look at this water feature class, we have a lot of features there. We have transmission main, this one, which is a line feature. We have tank that supply that will serve as our source of water. It's a point feature. We have system valve. It's also a point feature. We have literal, that's those pipes that they lay all around. It's also is a line feature. So we have both line and point feature in this feature class. We just classify all of them as water. That is, these are features that has to do with water system in this layout. So now we are going to be using all of them for this network building. And so I'm going to select all. In case we don't need all of them, we can deselect. But in this case, we want to select all. Then I will click next. So that will be the next. Now, the next step is, do you want to preserve existing enable value? Now, the default is, now let me go to say all network features are initially enabled unless they belong to a feature class that already has enable feature. So I want to leave it as default. If you will look at our manual. Okay, they leave it as no. So let's leave it as no. We don't want to enable all network features. So now, say select the role of the feature class. Here, we want to create a role for this feature class. And we want to specify the one that will be the main network. In this case, in network modeling, we call it complex feature. We want to know the one that will be the complex feature. What is complex feature? Let me share something. See. Let's say this is one of our tap pipe, and this pipe supply water. Let's say this. Let me see if I can get a color here. We have a block here of land. Then there's a block also here. Don't mind my drawing. We have some blocks here also with parcels. So now, and we have a water network that supply water into every facilities in this block, like this. So this can be of many types, like this. Can go like this, go like this. Now, out of this network, this one, let me put it in blue, is the complex feature among them, because one, it cannot be broken, then every other network join to it. So we have to specify in our database which of the feature class is the complex feature. So that's what we want to do. Let me close this, share my screen again. Share. So I want to specify out of these 7 features, we have distribution main, then we have fitting, we have hydrate, we have literal, we have subvalve, we have tank, and we have transmission main. So we want to select which one will be the complex feature. Number 1, we want to select this distribution main to be our complex feature. You see, you just click on row, complex feature, complex edge. Then there's another one, distribution main and transmit main. This one down will also be our complex edge. So you see that in the drop down, we have complex edge and we have simple edge. The simple edge are those ones that just connect to the main. Hello, who's there? So now the simple one are the one that connect to the complex edge. So we have defined 2 now. We have the complex edge. We have we have the 2 complex edge now, which is distribution main and trans main. The other every other one, you see, for those that are point feature, you see that we just call them junction. So we call point feature in networking simple junction. They are just a junction. They are just a target point. So for those that are line, they can either have simple edge or complex edge. So in this case, we have only one simple edge, which is the literal that they will lay all around to join with the main distribution. So we click next. Now we are now in we are done with step 8. Let's go to step 9. But before that, say feature in geometry network must be precisely connected to one another. The input feature class can be adjusted to ensure connectivity by snapping. Now, you will specify whether this feature needs to be adjusted to snap to one another in network building process. So one of the major goal now is to ensure that all these features they connect with each other. There's no misclosure among them. But before then, there's also another thing we call weight in network. Now, in this regard, in this network, in this study, there's no much weight. I want to see where they talk about weight here. Coming. Click yes to okay. And check the. There's a place we'll talk about it. Okay. Save. No. So I will still figure it out. It's there. Now, for this, we don't have any weight, but in a simple, let me share in a Let me share another. Sorry, come. Like in this drawing, let's say this is not water network now. Let's say this is just a road network. Weight in this type of road network could be distance, because distance from traveling from here to this place is different compared to this. So we have different distances from one point to another. It could be travel time. Don't mind my handwriting. Could be travel time, that will be weight. It could be is there any obstruction? Maybe there is construction going on. So all these things have to be put into consideration when building a geometric network. I'm just citing example of road network now. But in this case, in our case, it's a simple case. There's no any attached weight. So let me close this and share this screen again. So now, I will just click next because I don't have any weight. So this is the summary of my input. Click finish. Then it builds my geometric network. So the geometric network has been created with 7 build error, right? The build error are stored in the water, but I don't know. I can't figure out the error now, but it has built the network. If you look at here, you can see the water network has been built. So the next thing we have to do is to create a connectivity rule. What did I mean by connectivity rule? How each pipe is linked to each other. Which of the feature will serve as source? Which one will serve as which one will serve as the sink? So that is what we want to do now. Okay, I think I see where I make mistake. Yeah. The issue with this manual is that it's using old version of AppMap. So some we may not be getting it exactly as it is here, but I will try and say click yes to. Let me come. Let me just go to connectivity room. Now, let's go to connectivity room. So network connectivity rule constrain the type of network feature that may be connected to one another and the number of feature of any particular type that can be connected to feature of another type. So I think the best thing for us to understand very well is when we look at road network also. Let's look at this as a road network. There are some roads that they are just double lane. The type of route that we connect to them, we have to specify it. It's not just any, we have different routes. We have primary, we have double lane, we have major highways. The way they connect, that's how connectivity in network building also work. So let me. So now, to create a connectivity rule, we have to right click on the class that we just created, which is this. which is a water network. When you right click, go to property. Now, that's the first step. So, geometric network property dialog box opened, as you can see. Then the dialog box provides information about future classes participating in the network and a list of network weights. So as you can see, we have future classes like rows, this distribution main, we have complex edge. Now, this source, I want us to, this tank, I want us to make it the source. It's like I will have to edit this thing back. I think this is where I make mistake. So this tank is supposed to be source, that's the source of water, so that if there is any linkage or if there is a want to track some fault in the network, you can easily track it. Let me try to figure this thing out. Should I delete water network? Let me just go to metric network. Next. Select all. Next. No. This will be complex. Then transmission may also will be complex. Then we have to specify the source now. The source will be tank, yes. Sorry, I hope we are together. I need a response. Hello? Hello?
Yeah, we are, because we are muted. I believe.
Okay,
Yeah.
I know. I just want a response. Well, I make mistake the other time, so I'm trying to figure it out now. In our network building, we must have a source and a sink. A source or a sink. So, and in this situation, we are making, sorry, let me go down, up. We want to make, I'm coming. We want to make our transmission main and the distribution main as our source. So I've already done it for, sorry, make mistake. I think the tank is one of our source. I want to see where they put it here. Okay, so we have to have a sink and a source are used to determine the flow direction. So you must specify which of these, if any of them are junction feature, can act as a source and is a sink in the network. So we specify only tank as our source, while others are junctions. So as you can see in this place, this has been specified as the source. So let me click next. I think that's where I make mistake. There's no any other weight. We don't have weight in this case. So let me process it. See how we robots. Let's continue. I will have to figure that out. So 1 minute more. Now, I want to go back to the connectivity rule. So we click on this property. So under the connectivity rules, we can now see that it gives me the general overview of the network that I've built so far. Just as I've specified tank as the source, he has noted it. Now, we click on the connectivity tab, that's the next step. So under the connectivity tab, we have to modify, say this tab lets you add and modify connectivity rule for the geometric network. You will first create a new edge junction rule, which states that hydrant can connect to hydrant literal. It also indicates that when a hydrant literal is created, the next step for us, after clicking on this water network and going to the property, it will first show us this. That's the general. That's where we see the general overview. We see which one is, we see the role of each feature class. And we see whether they are source or they are just ordinary edge. Then we go to connectivity. In this connectivity, we first want to define that of literal. So we can see that in this drop down we have all the feature class stated there. So we can define rules for each feature class. And the first thing, what we guide our rule, what is our rule? Let me just say that is that literal must connect to literal. So the rules state that, let me change this icon hand so that I can highlight some things. Okay. Okay. But the rule says that hydrant can connect to hydrant literal. No, hydrant are those water that they are meant to curb fire incidents in that layout. So if there's any fire issue, that's what they will open up to curb that incident. Then that means any hydrant must connect to hydrant. Hydrant cannot connect to a pipe that is taking in fresh water for drinking. So now it also indicates that when an hydrant literal is created, a hydrant junction feature should be placed at its free edge. So that's the first rule. So to implement this rule, we click the drop down and select literal. Then in the list of subtype in the feature class, click hydrant. That's in the list of subtype, this one here, we click hydrant, which I'll click now. Then the next steps is in the list, that's step 5. Now you will now click the type of junction that hydrant literal can connect to in the network. For simplicity, hydrant literal can only connect to hydrant. So we check hydrant in the list of subtype in the network. So this hydrant can only connect to hydrant. I hope you understand now. So hydrant literal can only connect to hydrant here. So we have to check the hydrant in the list of the subtype in the network. Now, step number 6. Click plus sign to expand hydrant. We click this plus sign here to expand hydrant. Then we are now at what? Right click hydrant under it. We right click. Then we click set as default. Then we have defined that. So you will see that a blue icon appear. If you are doing it when you are practicing, you see that a blue icon appear next to the hydrant subtype, indicating that is the default junction for this edge subtype. That is, anytime we are defining an hydrant literal, it must connect by default to an hydrant. We will see a real life application of this. I want to show us one application that actually implement this. And one good thing with this thing is that you can build it yourself, because if you rely too much on ArcGIS, you have to be paying them almost every year. Even to buy credit to store on their storage, you have to be paying. So you can build this by your own and make it your own application. So now the next one is, I think we have done with step 6. Let me go to step 7. Say you will now create a new edge to edge rule. And what does this edge to edge rule? The edge to edge rule states that hydrant literal can connect to distribution main. You know, it's carrying water, so it should be able to connect to distribution main through tap, tees, and shadows. Then the default junction for connection between hydrant literal and distribution main will be tap. So how can we accomplish this? Now, in the networks of type list, click the plus sign, expand it, just as has been shown. So in the networks of type list, click the plus sign here, then we expand it. So say check distribution main under it. Now, because you have checked an edge in the distribution in the network subtype list, the list of junction subtype in the network become active. Now, in this list, you can specify which junction type hydrant literal and distribution main can connect through. So in the junction subtype list, click the plus sign. So this junction subtype list here. So we have to click the plus sign to expand filtering. Sorry, it's not giving me. Oh, I don't know why it's not here. Filtering. Okay. You have to select this. That's this distribution main, so that we can filter it in junction subtype. So now in the junction subtype list, click the plus sign to expand filtering and check type. We will now check tab. We don't want shadow. Sorry. Let me uncheck all of them so that the only thing I will check there is tab. So I will check tab, that it can connect through tab. Then I will check till, that it can connect to till. Then I will check shadow, that it can connect to shadow also. In that order, notice that tab has blue next to it. This means that tab is the default junction. So majorly the major source of connection to the main distribution is through tap. So tap is our default, but it can sometimes connect to schedule and the T. So that's what that step is saying. Now, step 9, click OK. You have now added behavior to your geodatabase by defining connectivity rule. You should normally define many more connectivity rules for a network. However, for this tutorial, you only need to define connectivity rule specified here. In the next part of the tutorial, we will create feature link annotation for your new hydrant literal feature. That will be another time. But what I want to say here, let me just click OK to apply. So we have defined our connectivity rule now. Someone will say, how can we apply this? How can we use this to solve problems? There are a lot of ways. There is one application that is very common in Lagos now that people are using. They call it, I don't know who have encountered it, they call it lara.ng. If you go to lara.ng, it will open this application for you. Anywhere you are going in Lagos, just type the place that you are going. You can type it in this order. Let me copy their example here. This is from Balende. You want to go to, you are going to Ajah bus stop from Balende. Let me put it here. This is just a robot. By the time you place it for this robot and you send it just like as you are using WhatsApp, it will give you information, as you can see. It will give you information of how you are going to move from one place to another, the bus, the price. Now, what I want to bring out here is that underneath at the back side of this application, there is a database already, and that database has been networked together in such a way that any information you want, it knows how to link it together to get you to where you are going. Now, it attach weight to every route, and what is that weight? The price of getting there. It will even tell you the time. You see now, you say estimated time is 46 minutes. So if I'm in Obalende and I want to go to Ajah bus stop, I will spend 46 minutes. So that is one of the application of GIS. In fact, it can sense your location, can trap your location. Can you see here? It can trap your location. It will find my own location now, and it can give me this from my location to where I'm going. It will tell me this bus you are going to take, this bus you are going to take. So that's one application. And maybe in the later in all our subsequent tutorial, we will look at some of these things, how we can build our own application using ArcGIS and launching it. So that is what I have for today. I think by next week we'll be going to annotation, or we can look at it. We can just take it as an exercise. We can do it together. Annotation is about labeling all those tracks, and I don't want us to spend much time in annotation because the latest product of ArcGIS now don't want to be supporting this annotation format again because it's not easily rendered on web. Everything is now going to web, so they want to be dropping their support for it. But we still look at it if we are permitted. Is there any question?
Good evening, everyone.
Good evening.
Yes, my name is Gani. So I just want to ask a question based on this ladder. It's showing is, I think the app is a bit certain about the time you will arrive at your destination. So I want to
Yes.
combine, if it takes into consideration all this hold up and congestion that can happen along the road.
Yes, because they are updating this thing almost every day.
Okay.
That's number one. Number two is if you are form of using Google most times, it will tell you traffic along your path. Hello, hello.
Yes, I'm listening. I just moved myself.
Okay. So it will tell you. I think they are updating it. To answer it in a simple way, it's being updated because even it's like Google want to buy it now, buy this Larados engine,
Yeah,
but
and also
they want to collect data for the whole country. So I think they will upgrade it in the near future. It will tell you, like today now, as at 3 a.m., there was a serious accident along Lagos Ibadan Express Road. So if you are moving along that path and you are using this app, it should be able to tell you if you are time, like where you're supposed to get to in the next 30 minutes, it just give you like 5 hours. You too have to rethink before leaving home. So